Hey everybody, and welcome to this video on section 10.1, an introduction to financial mathematics. So as with the syllabus video, let me apologize for having to present the information with a video. I would much rather be with you in class so I could sort of see your faces and see what sort of problems or issues you have. But so I'm aware this is not optimal, but this is the best we can do given that I have to miss the first 2 days of class. So if something in this video bothers you, please let me know. Please email me and we can straighten it out hopefully by Monday when I get back. Okay, so first of all, just an introduction to financial math in chapter 10, just very broadly here, right? I don't think I need to motivate to you why financial math matters, but here you go. As a consumer, you make decisions about money all the time. Many of these decisions are minor, like this middle question here, right? Should I get gas at the station on the right or make a U-turn and go to the other station that's a little farther away, but gas is a little bit cheaper, right? So if I'm driving with my wife, the answer is always go to the other one where gas is like a penny cheaper, But you could sort of try to do the math on that and see if that makes sense from a miles per gallon standpoint or whatever. Some questions, though, are major. So here's sort of a more major question. I'm going to buy a new car, and when I do that, the dealer is going to give me different options. So a lot of times they'll give you like 10 options, but just to keep this question short, perhaps the dealer offers you a $2,000 rebate, or they offer you a particular financing option. So you can take no interest for the first 60 months. Whoa. 60 months. That's pretty long. Surely I meant 6 months, but whatever, right? Should I take some money up front or should I take 0% interest for 6 months, so for some amount of time? So the more major questions are the focus of this chapter. So in your life, right, you're going to need to be dealing with money. In particular, you're going to be dealing with things like loans and credit cards, and that is what this chapter is about. Up front, though, before we do anything, section 10.1 is about percentages, okay? So interest rates on loans are couched in terms of percentages. Yield rates on bonds are phrased as percentages, okay? So before we do any sort of real financial math, we need to think about and be comfortable with percentages and things like percentage increase, percentage decrease. So that's what this section is about, and therefore that's what this video is about. So let me just remind you, I assume many of you might be rusty on this, many of you might not be, but whatever. A percentage is just a way of converting a fraction to a number. Okay, so 90% would be like 90 over 100 is what this is saying, right? 5% would be 5 over 100, right? So there's an equivalence between fractions and percentages. Percentages oftentimes are just an easier way of thinking about a fraction. It conveys more information to write 5% than to write 5 over 100. Okay, so percentages are useful for many reasons, and one of them is this middle paragraph here. They give us a common yardstick to compare different fractions. They provide useful ways of dealing with fees, taxes, tips, interest rates, things like this. They help us better understand how things go up or down relative to a baseline. Here are just some reasons why percentages are useful or important. So let's delve into some examples here. So first of all, let's just deal with conversions from fractions or decimals to percentages. Let me just remind you how this works. Decimals can be converted to percentages when you multiply by 100. So the decimal 0.76. If you multiply that by 100, you get 76, so that's 76%. 1.325. If you multiply that by 100, you get 132.5, so that's 132.5%, etc. Okay, so as I'm sure you learned at some point, right, going from decimal to percentage means taking the decimal point and moving it 2 spots to the right. So that 0.76, you go womp, womp, right? 2 little jumps, 76. 1.325, womp, womp, 132.5 now, right? Okay, so that's how you convert, right? So, right, and if you have a number with no decimal point, like the number 5, you say, well, there's no decimal point there. Well, there is if you write one. right? So 5 is 5.0. So you move that decimal point 2 spots to the right. So and then 500%. Okay. So, and by the way, the converse is also true, right? So if you want to go the other way, you move the decimal point to the left. So if you have a percentage like 132.5% and you want it to be a decimal, just move that decimal point 2 slots to the left. Okay? So going from decimal to percentage is 2 jumps to the right with the decimal point. Going from percentage to decimal is just move the decimal point the other way. Move it left. Okay, so let's just start with a concrete example here. Suppose that in some class you have a quiz, a midterm, and a final, right? And here are your scores. 19 out of 25 on the quiz, 49.2 out of 60. This English professor likes fractional points, I guess, on the midterm, and 115 out of 150 on the final. So what was your best score? Well, you could just say 115 is the best because it's the biggest. But of course, I think you all see the flaw with that, right? 115 versus 19 is not a fair comparison, right? Because that 19 was out of 25, whereas that 115 was out of 150. So the raw scores don't tell you much about quality, especially not relative quality. So you just compute the percentages, and you compute them as fractions. And hopefully you all know to do this, but if not, all you do is form the fraction. 19 out of 25. 19 over 25. Ask your calculator what that is. 0.76, which is 76%. Right? Move that decimal point over 2. The midterm score, 49.2 over 60, is 0.82. Move the decimal point over, 82%. And then finally, 115 out of, sorry, I have the wrong line here. I don't know what I was doing here. But anyway, 115 out of 150 is 0.7667. That's 76.67%. So that score is definitely not the best one. This line should have appeared under this bullet point. I'm not sure why I got that moved. But anyway, so the point here is just this, like, why are decimals useful or percentages useful? They give us a common yardstick, right? That's what's happening here. These exams and quizzes are out of different denominators, out of different point totals. So the percentage helps you cut through all that. Right, so you can just say, oh, I'm comparing 76 to 82 to 76.67, right? So 82 is the best. Okay, so here's another example. Imagine you take a friend out to dinner for a birthday. The bill comes to $56.80, and your friend suggests you should tip 3/20 of the bill. This is obnoxious. Nobody says this right, but just go with this example. So the question is, well, what do you do with that fraction? That's an annoying way to phrase what you're doing, right? Well, 3 over 20 is just 0.15. So your obnoxious friend is just suggesting you tip 15%, right? So this example is kind of dumb because nobody does this, but it is just, again, illustrating that fractions can be sort of hard to even look at, right? What kind of tip is this? The percentage, though, is easier to read. Okay, so that's the point of this. Percentages can be easier to look at, easier to understand than a fraction, say. So now 15%, you just take 15% of the bill amount, which was $56.80, and you get a tip of 8.52. And hopefully, by the way, you know that the word of, when I say 15% of, that corresponds to multiplication. So here's 15% as a decimal of, so times 56.80 gives you your 15% number. Okay, so now let's go to percentage increase and decrease. So imagine you have some money put aside. You're going to buy yourself an iPod. I don't know if this price is reasonable or not. I didn't price out iPods. This seems expensive to me, but whatever. So just take the numbers at face value in this example. Okay. So let's say the price of the first iPod you see is $399. Well, as is usually the case, right? There's going to be a sales tax. And sales taxes are phrased as percentages. That's how they are presented. So you're not going to pay $3.99, as I'm sure you know. You're going to pay more than that, right? Well, how much more? And how do you calculate that? Well, you take $3.99, and then you add 6.75% of it. So the 6.75% of $3.99 is this 26.9325 number. That's the tax amount, right? That's the money that the state takes as a sort of fee for that transaction. So the store gets $3.99 because that's their price. This goes to the state, and you end up paying $425.94. Okay. Now, the reason this is in this percent increase and decrease section is, notice you started with some price and it got increased, right? The sticker price was $3.99, but that got increased to $425.94. You could ask, what kind of increase was that? Big increase, small increase, whatever. In this case, it's not a very big increase, and the exact amount by which you increased the price was 6.75%. That is how a percent increase works. You start with some baseline number, add some percentage of that number, and you get some new price or new number. Okay, so this calculation I did here, $3.99 plus some percentage of it, that can be shortcutted to this. I have 6.75%. If I write it as a decimal, just slap it on the end of 1. So this is now 1.0675 times $3.99. So you take $3.99 and you multiply it by a number a little bigger than 1. And in fact, it's 6.75% bigger than 1. And that's how you get this slightly bigger number here of $425.94. So if you want to increase anything by 6.75%, you can just do 1.0675 times the original number. Okay, so at another place, there's a $415 iPod. You have a coupon, though, 5% off. Okay, so how does that work? Well, if 5% off is what you're taking, that means you have to pay 95% of the original price. So that's where this computation comes. Here's 95% of that price, which is $3.94. That's what your coupon does for you, right? So this is a decrease. Right, you started with $415 and ended up with $394.25. This was a 5% decrease because you're paying 95% of the price. That's what it means to have a percentage decrease of something. However, this $394.25 is not the final price because this store also has sales tax, right? So I get my discount, but then they're going to charge me tax on the resulting amount. So, same tax rate of 6.75%, so now I have to increase my sale price by 6.75%, and I get $420.87. And if you want to just do all this in a single step, you could say, okay, here's my 5% discount. I take care of that first, 95% of $415. Then here's my sales tax increase right there. So step 1 was use the coupon. Step 2 was apply the sales tax, and you get $420.87. Okay, so this is what it means to have an increase or decrease by percentage. I started by a 5% decrease, then I applied a 6.75% increase. Okay, finally, one last option. You see an iPod online for $441, which seems pretty expensive. But whatever, that price includes a 5% shipping and processing charge that you don't have to pay if you just drive to the store. And the nice thing about driving to a store in Portland is there's no sales tax there, at least as of the writing of these slides, you know. So what? They've been updated since, but this is 2014 was when the slides were originally created, you know. So anyway, they've been updated since then, but so I don't know if this is still true. But okay, so that $441 is much higher than the sticker prices of the other ones. But, you know, what if you could just drive to the store and then not pay sales tax, right? What would happen then? Well, first of all, right, this 5% shipping and processing charge that was built into this would come off, wouldn't it? So that would make this price cheaper. Also, there's no sales tax, so you don't have to do this 6.75% increase thing at the end. So all you got to do is take 5% off of that. Okay, and so here's what that computation looks like. So the 5% was added to the original price to come up with this new thing. So what happened was, I have some original price that I don't know. That's what I'm thinking about looking for, right? But that original price was increased by 5% to give me 441. So if you want to unwind that process, if you want to figure out what that p-value is in that equation right here, that original price, you can divide both sides of this equation by 1.05 to get $420. So in other words, if you start with $420 and increase it by 5%, you get 441. If this move here bothers you, this is sort of what I mean by basic equation solving as something you're expected to know. If this bothers you, please let me know. Okay, you might be rusty on your algebra, and that is fine. Okay, so we can talk through that. But you should understand what this equation is saying here, right? There's this original price that I didn't know. But what I did know about it was that if I increase the price by 5%, I get that 441 number. So with this equation in hand, all I have to do is isolate this p number to see what it is. And to isolate this p, you divide by 1.05 and get 420. Okay. So, this third option actually turns out to be the cheapest, but that second option is just a few pennies more, and you don't have to go to all this trouble of getting your friend to pick up this iPod for you or whatever, okay? So I want to formalize this in the next part of the video. So I'm going to stop the video here just for the sake of time. But this is the idea of a percentage increase or decrease. Basically, you are multiplying numbers by more than 1 for a percentage increase, or you're multiplying numbers by, say, less than 1 for the corresponding percentage decrease. Okay? So we will finish this video, or this material, in the next video.